Hello everyone, and today we're going to learn how to solve equations in factored form, and also we're going to learn how to solve equations using GCF. Alright, so first thing we have to start off with is the zero product property. Now what that basically says is that when in an equation, if we have A times B equaling 0, the end result can be that either A could be 0, B could be 0, or both of them could be 0 technically. Okay, so that's what that basically says. From this, where I have two pieces multiplied together and it equals 0, okay, that means either the element A could equal 0, because 0 times B would therefore be 0. It also could mean that the element B is 0, which means A times 0 would equal still 0. Okay? Now, to start off, we're going to have a couple of problems here, a couple of example problems. All right? Now, in my first one, it says that x plus 4 and x minus 3 multiplied together is supposed to equal 0. Okay? So let's zoom in on this problem. Hey, where are you going? There we go. Okay, so let's solely look at this problem first. Okay, now what I'm going to do is basically, knowing that one of these pieces has to be 0, either this one is 0 or this one is 0. So I have to be able to figure out how or which one of these pieces is 0, or what would give 0 in those parentheses. Okay? Now, in order to do that, it's really quite simple. All we're going to do is take our two pieces in the parentheses, so here x plus 4 and x minus 3. I'm going to pull these guys apart like so. Then I'm going to set them equal to 0, because this now sets me up saying which one of these guys could be 0, and if that's the case, what would those x's have to be to give me 0? Okay, so then we solve these little equations. So here I'm going to minus the 4 to solve for x, get x alone. Okay. Therefore, x equals negative 4. Okay, so in one aspect, I could have x be negative 4 and have 0 as a result, and I'll explain and show you that how and why in a minute. Now let's go to the second piece here. All right, so I'm going to add 3 to solve the little equation. Okay, therefore, x could equal 3. Now, in the beginning stages, this confuses a lot of students because of the fact that you guys sit there and say, well, gee, how can this be two answers at once? Well, that's because we've got two values here that x's could be. That's why, and we have two x's plus 4 minus 3, and the end result is one of these guys is going to end up being 0. So let me show you how and why this is going to work to be 0. I'm going to scooch out a little bit, give myself a little more room. Alright, so let's take a look at the first one. Okay, we said in one instance that, that x equals negative 4. So let's take a look at when x is negative 4. So I'm going to take my problem. So I'm going to have x plus 4 and x minus 3 equaling 0. And again, I'm going to fill negative 4 in for x. Okay, so here I go. So negative 4 plus 4 and negative 4 minus 3 is supposed to equal 0. Now when I do this and I add this up, right? So let's do it. Negative 4 plus 4 is, well, 0. negative 4 minus 3 is negative 7, equaling 0. And then when I times this all together, well, 0 times negative 7, as we all know, is 0. So, okay, so students will say, okay, well, I get that one. So how can it be negative 3? But in the same aspect, folks, okay? So if x equals 3, I set up my problem as x plus 4 and x minus 3, minus, is equal to 0, minus, okay? Now, this time we're going to put 3 in for x, so let's say 3 plus 4 and 3 minus 3 is equal to 0. Now, most of us could see already that it is going to work out to be 0, but I always get those students every year, well, gee, aha, I got you. 3 plus 4 is 7, that's not 0. Yeah, we haven't finished the problem yet. Yes, that is 7. But here, 3 plus 3 is 0. And when I times this all out, 7 times 0 is still 0. So that's how and why this can be two answers at the same time. Okay. All right, so let's look at the next one. Okay. So here we go. Let's start off. First thing I'm going to do is kind of pull these pieces apart. Okay. Because one side 0, that's very important too. I forgot to mention that. One side of this thing has to be 0 for this to work. Okay. Now, one side 0, so I got what I want there. So now let's pull these pieces apart. X minus 4, x minus 7. Okay, we're going to set these things equal to 0. Equal to 0. And then we solve the little equations. Okay, so here, if x minus 4 is equal to 0, to solve this, I would add the 4's. So x can equal 4. All right. Now here, in this equation, x minus 7 is 0. So again, what I'm going to do is I'm going to add 7's. Okay. So when doing that, okay, I get x also equals 7. And here are the two answers to your problem. X is 4 and x is 7. Okay. I'll do this next one with you as well. So let me scooch out. Go all the way over here. Put that right there. Yeah, that looks good. Okay. So again, nothing too crazy. First things first, does one side of this thing equal 0? Well, yes, it does. So we're good there. Our next step is let's pull these pieces apart. Okay. So x plus 2, x plus 8. Okay. Now, we put these equal to 0. Like so. Then we solve the little equations. Okay. So minus 2. Therefore, x equals negative 2. Okay. Now on this other side, I'm going to minus some 8's. Therefore, x will equal negative 8. Done. It's that simple. Now, one other thing in this page that you should know, because you will see this term come up again time and time again, and students always ask me, well, gee, it's telling me to look for the roots. What does that mean? Well, the answers to these problems are called the roots of the problem. So, for instance, in our problems up here, like we said in this first problem, x equaled negative 4 and x equaled 3, those are actually called roots. Just like these right here are called the roots to the problem. And these right here, the answers, are called the roots. So when you hear an equation talking about finding the roots, it really means just factor to solve this thing. Okay? And we're ready to move on. All right, so here's one for you to try. Okay? So I'm going to step away. Again, leave the video running. Okay? I'm going to give you guys about a minute to do this, although for most of you this should take no more than 30 seconds, so you can get started. And again, we'll just leave the video running. Again, I'll step away for 1 second, and then we will come back to you, and I will talk about how to solve this problem, and then go from there. Alrighty, folks, we should be ready, right? All right. So looking at this thing, the first thing I look for is one side of this thing equal to 0? And the answer is yes, so we're good there. All right, so now what I'm going to do is I'm going to pull these pieces apart. X minus 5, x plus 8. All right. Now I'm going to set the pieces equal to 0, equal to 0. And then from there, we're just going to solve the equations. So here, if x minus 5 equaled 0, add the 5s. Therefore, x equals 5. Over here, if x plus 8 equals 0, when I minus 8s, therefore, x equals negative 8. And there's our roots, or the solution to this problem. All right, here's another one to try. Again, get going on this one. Again, leave the video running. Again, and I will step away for about 30 or 35 seconds or so, and I'll let you guys work this one out. And then from there, I'll come back. We'll talk about how to do this and go from there. All right, so try this one, folks. Alrighty, folks, I'm back. Alright, so here we go. First things first, does one side of this thing equal 0? Why, yes, it does. So we're all set there. So now I'm going to pull these pieces apart. X plus 14. X minus 7. Okay. Equals 0. We got to set these pieces equal to 0 now. And then we're going to solve what we got. Okay. So if x plus 14 equals 0, so we're going to minus the 14. Therefore, x equals negative 14. All right, coming over here, if x minus 7 is equal to 0, I add the 7s. Therefore, x equals positive 7. And again, here are the solutions, or again, as math people call these things, they're the roots. And then we move on. All right, here's a third one for you to try. You guys should be getting very good at this by now. Again, this isn't too difficult yet. We're going to have some fun with this in a little bit. Okay, so again, I want you to try this one out. I'll give you about 30 seconds to do it. And then we will go from there. So again, leave the video running. And I will come back in about 10, 15, 20 seconds or so. And we'll go through this one. All right, folks, I'm back. All right, so here we go. First things first, whoops. Does one side of this thing equal 0? Yes, it does. All right, so let's pull these things apart. Okay, so I get x plus 12, x minus 7. Whoops. Okay, let's set these pieces equal to 0. Equals 0, equals 0. Now, let's solve what we have. So here, if x plus 12 equals 0, if I minus 12's, x equals negative 12. If I go over here, if x plus 7, or correction, if x minus 7 is 0, I add the 7's, therefore x equals positive 7. And again, here are the solutions, or what we call the roots to the problem. All right, here's another easy one for you to try. Okay, so again, leave the video running. I'll step away for about 30 seconds, let you guys do this one up, and then we'll go from there. Alrighty, folks, I'm back. Now again, first thing I'm going to do, is one side of this problem 0? Yes, it is, so we're good there. So I'm going to start by pulling these pieces apart. So if x plus 4, x minus 4, I'm going to set the pieces to 0. Okay. Now we're going to just solve what we got. Okay. So here, if x plus 4 is 0, I'm going to minus the 4 from either side. Therefore, x will equal negative 4. And here, if x minus 4 is equal to 0, if I add 4's to either side, therefore x equals positive 4. So again, the roots, or the solution to this problem, are x equals negative 4 and x equals positive 4. All right, now with these, we have to be a little careful. Okay, they look simple enough, but again, in one of them, we're going to have a weird solution set for this. The other, we're going to have fractions. And I know how much you guys love fractions. So, again, in case I'm missing a fun fraction Friday, or for those of us who you guys have missed a few fun fraction Fridays, we have to take a look at those. So, let's start with this one over here first. Okay? X plus 3 and x plus 3 equals 0. All right, seems simple enough. But let's follow our steps. First things first, does one side of this thing equal 0? Yes. All right. So now let's pull the pieces apart. X plus 3, x plus 3 again. Okay. Now again, like we've been doing, we're going to set these things equal to 0. Okay. Now from here, we're going to solve the equations. So here, if x plus 3 equals 0, I'm going to minus 3's. Therefore, x equals negative 3. Now, because this is the same thing, I know that x is going to equal negative 3 again. Now, properly, you can say this. You can leave it like this. That's perfectly fine. Okay, but properly, what we should say is x equals negative 3 dr. Now, what dr means is a double root. And all that really means is when I see dr with an answer, that means that the negative 3 appeared twice. See, 1, 2 times when I was solving the problem out. Okay? So that just means if you're trying to keep track of answers in these things, that means this thing appeared twice in our set of answers. Now for the moment you guys have been waiting for, the fun fractions, because I know how much you miss the fractions. Okay, so here we go. First things first, does one side of this thing equal 0? The answer is yes. All right, so let's pull these things apart. 3x plus 2, 4x minus 5. I'm going to set these things equal to 0. Okay. Now let's solve them out. So here we're going to start over here. So first thing, I'm going to solve the equation normally. So again, I'm going to start it by minusing 2. So 3x equals negative 2. And again, do not leave it like this. I could care less what 3x is equal to. I need to know what regular x equals to. That's all I'm interested in. So we've got to get rid of this 3. And again, over the years, it's been a while since we solved equations, folks. Some folks say, oh, I'll just subtract it. No, remember, when a number and a letter are next to each other like this, that indicates multiplication. So to undo multiply, we have to divide both sides of the equation by 3. X equals, now again, 2 over 3 does not reduce, so our solution on this side is negative 2/3. Okay? Now in this case, if you wind up with improper fractions, you can leave them, but you have to reduce. If you don't reduce, you're going to lose points. Okay? Now, let's come over here. So again, I'm going to add 5s to start solving this thing. So 4x now equals 5. Okay, I'm going to divide both sides of the equation by 4. Therefore, x equals. Now again, I cannot reduce 5 over 4, so I'm going to write this as 5/4. Now if you want to, yes, you can convert that to 1 1/4 if you want, but I think it's a lot easier just to leave it like this. But again, that's up to you. Okay, I would leave it like this because as we've seen in the past, like with a system of equation, if I have to plug that 5/4 back into the equation, it's easier to use 5/4 than 1 1/4. So there are our roots to this problem. All right, so now we come to the second part of our lesson, factoring using GCF, greatest common factor. Now the greatest common factor is the largest possible multiple, and here's the key piece right here, folks, shared by all pieces. Okay, that is a very, very, very key thing right here, folks. It has to be shared by all pieces for it to be a greatest common factor. Okay? So the largest possible multiple shared by all pieces that can be divided out of the problem. Okay? So let's take a look at this first example. Okay? So I have 12x plus 42y. Now again, I'm looking for something that all the pieces share that I can divide out. The biggest possible number. Now again, for some folks, you can easily see it. It's obvious what the number will be. For some folks, it's not so obvious. So I'm going to take that approach with this one. I'm going to assume that some people looking at this problem can only see the smallest possible factor. Okay? So looking at this thing, they would see, well, let's see, I've got 12 and 42. So I know that it's divisible by 2. Okay, because the numbers are even. Okay, so they start dividing. Well, 12 divided by 2, that's 6. 42 divided by 2, that's 21. Now, x's and y's. Now, are x's shared with all pieces in this problem? Well, this guy over here does not have an x, so no x's. Same thing with the y. This has a y, but this piece doesn't, so the y's stay. But it is very important that if you do take the smallest piece, or even in general, always look inside your parenthesis again. And let me change color, that looks terrible. Always look inside here to make sure you got everything. Now looking at this, I have 6 and 21, which I know is divisible by 3. So I am going to kick out a 3 with the, all right, this 2 is this guy right here. This 3 is what I just took out. And now I'm dividing these pieces, this here, 6 and 21, by this 3. 6 divided by 3 is 2x. 21 divided by 3 is 7y. Okay. Now I'm going to look in here again. Now I'm looking in here. Can I take any more? No. 2 and 7 are not divisible by anything. So my last thing to do is multiply these pieces together. And I get 6 parenthesis 2x plus 7y. Now this guy out here, that is our GCF. Okay, but get in the habit, and again, tonight's homework is going to ask you what's just the GCF, but get in the habit of doing all of this, because this is going to be factoring in the future. So just get in the habit of just doing it all like this. Okay? Now, let's go to the next one. All right, so I have 4x to the 4th plus 24x to the 7th. All right, now with this one, I'm going to start with assuming that you guys can see the biggest common factor with the regular numbers. So I look at the regular numbers, 4 and 24, and I think, what do these pieces share that I could take out? And the largest multiple they share is a multiple of 4. So I'm going to kick out that 4. Okay, so 4 divided by 4 is 1. 24 divided by 4 is positive 6. Okay, now for the x's, and I'm going to scooch this down 8. Oh well, I'm going to take that for a second. Now, here's where we have to be careful. A lot of folks really mess this up too. Okay, we have to kind of think in terms of the Price is Right. Remember, you know the showcase showdowns in the very beginning, where they show you something and the contestants have to bid on the price without going over. That's what we're going to do here with the x's. We're going to take the largest amount of x's possible without going over. Now, we think about it. X to the 4th means there's 4 x's here. X to the 7th means I've got 7 of them. So then the question becomes, well, how many x's can I take out without going over or taking too many? And the answer is, well, I can take 4 of them. So again, we look to see 1, 1. So I can take 1x. 2 and 2, 2 x's. 3, 3 x's. 4, 4 x's. See how they share 4 x's all together. So I can take out x to the 4th power. Okay. Now we have to think about how to finish this off. Okay. Now, so these x's are divided off, so they're gone. I cancel off, they go away. These x's here are canceled off. We already took them out, so they're gone. So I have to think about what's left over. I have 3 x's left. So that's x cubed. Okay. Now, can I do anything else with this? No. Now again, people are tempted and they tell me, well, gee, yeah, I can take this 1 and I can do this. I'll just say this is 4x to the 4th and make this 7x cubed. Again, you can't do that because remember, the exactly rule of variables says that in order to add and subtract coefficients, there are numbers in front of the variable behind has to be exactly the same. This x cubed and this doesn't have an x are not the same, so you can't add them together. I also have students do this. 4x to the fourth, and you know what? That one's kind of really not worthless anyway. So I'm going to do this. No, you can't do that either. That one is here for a reason, folks. You can't just make it go away because you want to. No matter how hard you wish or try or hope it wasn't there, it's there, folks. So the final answer to this thing is this. All right, let's go to the third one. Little more fun because we have more letters to play with. All right. So here we go. All right. So first off, let's start with the regular numbers. Between 8 and 26. What common multiple do these guys share that I can take out? And the answer is, well, 2. That's the biggest one I can take. I can take out a 2. Okay, parenthesis, and I leave some room. So 8 divided by 2 is 4. Negative 26 divided by 2 is negative 13. Now let's go to the x's. Between x to the fourth or x to the fifth, how many x's can I take out without going over? And as some of you have may figured out already, and if you haven't, I'm going to tell you the trick. We always look for the smaller exponent. In this case, I can take out 4, so that's the one we go for. X to the fourth. Come on, 4. There we go. And now, we do kind of the mathematical hokey pokey here. I had 4 x's in. I take 4 x's out. So how many x's are left next to the 4? Is none. Next part. I have 5 x's in. I take 4 x's out. How many x's are left? Well, 1. So x to the first, or x. Now, let's go to the y's. Okay? Between y to the 8th or y cubed, how many y's can I take out without going over? Well, 3 of them, right? Okay, smallest one I can get. So here, I have 8 y's in. I took 3 y's out. So how many are left? Is 5. Y cubed, I have 3 y's in. I take 3 y's out. How many y's are left? Well, none. And this right here is our final answer. Fun, huh? All right, folks, let's have some fun. Let's take a look at something like this beast. Again, nothing too crazy, but we have to be careful of this one because it does have a nasty little trap waiting for us. Okay, so you know what I'm going to do? I'm going to let you try this out for about a minute or so. So keep the video running. I'm going to sit back and kind of relax a little bit here and give you about a minute or so to process this. I want you to factor using GCF. And then afterwards, I'll come back and I will teach you how to do, well, not teach you, I've already taught you, but I will go over how to do this problem. Okay, so again, I'll give you about another 40 seconds or so. You should have gotten started already. So again, keep the video running and good luck and have fun with this. Alrighty, folks, I'm back. Alright, so let's start taking a look at this thing, okay? So I start with the numbers first. I got 24, 18, 33, and 42. So what do they all share? Well, easily a factor of 3. So as I divide this thing out and leave some room, I'm going to have 8. 18 divided by 3 is 6. 33 divided by 3 is 11. 42 divided by 3 is 14. All right. Now, let's go to the x's. Between x to the 10th, x to the 12th, x to the 8th, or x to the 6th. How many x's can I take out? Well, the smallest one I got is 6. So x to the 6th. So 10 x's in. I take 6 x's out. 4 x's are left. 12 x's in. I take 6 x's out. So 6 x's left. 8 x's in. I take 6 x's out. I've got 2 x's left. 6x is in, 6x is out, nothing left there. All right, let's go to the y's. I have y to the 6th, y to the 9th, y to the 8th, and y to the 7th. All right, so here we go. Looking at my y's here, I've got the lowest one I have is 6. So let's take out y to the 6th. All right, so here we go. 6y's in, 6y's out, nothing left. 9y's in, 6y's out. I have 3y's left. 8y's in, 6y's out, 2. And I have 7y's in, 6y's out, so only 1y is left. All right. Now let's go to the z's. Between z to the 5th, z to the 15th, z to the 8th, how many z's can I take out? And a lot of people will go, well, gee, that's easy, that's 5. And you would be wrong. Notice over here, this does not have a z, so technically if you want to think about it the hard way, mathematical way, this is z to the 0th power. So how many z's can you take out is none. Because remember, the rule to greatest common factor, it has to be shared by all pieces. And in this case, the z's are not shared by everything. Therefore, the z's just go back as they are. Z to the 5th, I have z to the 15th. I have z to the 8th, and no z on the end. So this right here is our solution to the problem. All right, these guys we have to be careful with. Okay, so let's zoom in with this. Now students will sit here and say, okay, so let's start taking out what they share. And the thing that students forget about is these negatives. When the negative is shared by both pieces, I can take out a negative with my number. So as most of us see, 12 and 16, I can take out a factor of 4. Because both of them are negative, I can take out a negative 4. Because of the fact that both pieces were negative to begin with. Okay? Now, oops, hold on. I don't need that. Now, so let's start off. Let's break this down. So negative 12 divided by negative 4 is 3. Negative 16 divided by negative 4 is positive 4. All right, and then we just run the gambit. X's, I have x and x squared. So how many x's can I take out? Now remember, this is x to the 1st over here. No, not x to the 11th. X to the 1st. So technically, I can only take out one x. No x. And I have x to the 1st here. Y to the 8th and y to the 4th. I can take 4 y's. So 8 y's in. I take 4 y's out. I'm left with 4. 4 y's in. I got 4 y's out. So nothing left there. It's all said and done with this one. Okay. All right, now this. A lot of students freak out with a problem like as simple as this. So let's take a look at it so we can clean up any confusion. Okay, so we start with the regular numbers. Between 3 and 5, what do they share that I can take out? Well, 1, yeah, that's true. So if you want to put the 1 out there, let's do it. 1. So I have 3 and 5 because, again, 3 divided by 1 is 3. 5 divided by 1 is 5. Okay. Now let's look at the x's. Well, between x and nothing over here, I can't take out any x's. Okay. Look at the y's. Well, this got a y, but this guy doesn't. So I got to put the y there because I can't take it out. So my question is, yes, it's true. You can have a 1 out here, but is it really necessary? No. You can leave it right like this. So technically, in this case, folks, the problem was the solution. It couldn't be factored. Now, again, for those of you who did all that work and want to keep the 1 out there because it makes you feel comfortable that it's there, you're more than welcome to keep it there. But it's really not all that necessary to have. All right, now we go back to the whole point of the lesson. We're solving equations with factoring. Okay, so the first step when we're doing this, as I said before, make sure one side of the equation is 0. Done. Next step is now, instead of just saying, oh, it's easy, we'll just pull the piece apart. We now have this new step is to factor. And students hate this step because it's a general step. As we learn more factoring things or factoring rules or techniques, we're going to add to this list. But right now, all you know is GCF. So let's look at this. I can take out a 2, leaving me 3 and positive 2. I also can see I can take out x's, so I'm going to take out an x, and nothing here. So that's step 2, factor. Now I look in the parentheses just to be sure. I don't see any exponents here, so that means I can't go any further in terms of factoring. So we move on to the next step. Step 3 then says we're going to pull the pieces apart, like I just did here, like we were doing earlier. Pull the pieces apart. We set the pieces to 0. And we solve what we got. Okay, so here, 2x equals 0, so I divide by 2. X is 0. Now here, 3x minus 2 is 0, or plus 2 is 0, so we minus the 2's. So 3x equals negative 2. Divide by 3. Therefore, x equals negative 2/3. And remember, these answers are also called roots. And it's that simple. All right, we'll try this one. Again, I'll work this one with you because we only had that one quick example. Okay, so first things first, make sure one side of the equation is 0. Done, it is 0. Step 2, factor, and the only way you know right now is GCF. So looking at my numbers, I can take out a factor of 6, and my variables, I can take out an x. Okay, so 12x squared divided by 6x is 2x. Negative 18x divided by 6x is minus 3. And then we solve this out. Okay, pull the pieces apart. 6x, 2x minus 3. Set them to 0. And solve this. Divide by 6. X is 0. Here, 2x minus 3 is 0, so we add 3's. So 2x equals 3. Divide by 2. So x is 3/2. So there's our solutions to this problem. All right, here's where we got a problem. Problem is this. Step number 1, make sure one side is 0. Well, I don't have that here. Okay, now the thing to watch for here is this square. The coefficient of the lead piece, in this case the piece with the biggest exponent, which is the square in this problem, should always be positive. Okay, that's going to determine what's going to move. Now again, since the coefficient of the lead piece, that is the piece with the square, is positive, that tells me I'm going to move this to the other side of my problem. Now, if it were negative, say the 10x squared said negative 10x squared, that would tell me that I'm moving that to the left side of the problem, making the x squared positive again. Okay, so I'm going to move this piece over. So 0 equals 10x squared minus 8x. And again, oops, I forgot to explain. To move this piece, remember, we're going to minus 8x over. Okay. Now, some of you were asking me in the last section, well, is it important to have descending order? Well, when we were foiling or Tor attack or, box methoding or basically multiplying binomials or trinomials, it's kind of important, but not really. When you factor, it is very important that you have descending order, and that means that the exponents go in a descending order. They count down. So 2, 1, and if there was another, it'd be nothing there, no x's. Okay. Now, so we now have one side 0. So our next step says to factor. So parenthesis up. Okay. So looking at my numbers, I can take out a factor of 2. Okay, leaving me a 5 and a negative 4. Between x squared and x, how many x's can I take? Well, I can only take 1, so that leaves an x and nothing here. And for fun, I'm going to put the 0 now on the other side because a lot of people like it there, and it's okay to flip it at this point if you want. Now, pull the pieces apart. Set the pieces to 0. Solve what you got. So here, divide by 2. So x is 0. On the other side, add 4s. So 5x equals 4. I'll bring this up here so we can see it better. 5x equals 4. So divide by 5. X equals 4/5. And we're done. There's our solutions, or roots. All right, now again, let's really have some fun with this because you're going to like fractions. All right, make sure one side's 0. Done. Okay, factor using greatest common factor. Now, it's going to be kind of weird in this instance because, like I said in the beginning, greatest common factor is the biggest multiple they share that we can divide out. Well, believe it or not, looking at my denominators of 2 and 2, my greatest multiple is 1/2. So I'm going to take out or divide out the 1/2. Now, in dividing out a half with these guys, all that means is we're getting rid of the denominator. So that's going to leave 3x and the 5x squared. Pretty neat, huh? Now, we still have more work to do with GCF because, look, I've got an x and an x squared. So I can take out an x with this. So 1/2 x, and I now have 3 plus 5x equaling 0. All right, so now pull the pieces apart. 1x divided by 2. 3 plus 5x equaling 0. Set the pieces to 0. And solve what we got. Okay, so here I'm going to get rid of the ugly fractions because it's an equation now. So I'm going to times by 2. So that cancels. So I'm left with x equaling, now be careful here, 2 times 0 is 0, not 2, folks. A lot of people make that mistake. Over here, I'm going to minus the 3's. Whoa, I got like, let's get rid of that. No. Minus the 3's. I've got too many equal zeros over here. 5x equals negative 3. Divide by 5. Therefore, x equals negative 3/5. It's that easy. All right, I'll let you try this one on your own. I'll give you about 30 seconds or so to do this, and then I'll come back and talk to you about it. So again, leave the film running, and I'll come back and we'll talk. Good luck. All right, let's talk. First things first, make sure one side's 0. Boom, it is. Factor using GCF. These pieces share a multiple of 6. So I'm left with 3x minus 2 is equal to 0. Now, pull the piece apart, set to 0, solve. All right, pull the piece apart. 6 and 3x minus 2. Whoops. Now, Set the pieces to 0. Equals 0 equals 0. Now solve. Now here's the thing though. Notice how this guy doesn't have a variable. So that's a direct statement. This says, flat out, 6 equals 0. Now in the mathematics you are aware of, 6 never can equal 0. So this is a bad answer. So we're going to just throw that away. That's no good. Can't have that. Now here, because I have an x, I can solve this. So I'm going to add 2's. 3x equals 2. Divide by 3's. For x equals 2/3. That's the only root we have on this one. Alright, next thing we're going to see tonight is the function notation. Now again, function notation, remember that when we see f of x, it really means y, so nothing really major there. Now the new thing is the zero function that says we're going to replace f of x with 0 in order to use the zero property of equality. Okay, the zero property that we've been seeing. Okay, so solve by factoring. We have f of x equaling 20x squared minus 12x. Now, using the zero function, that says I'm going to change this to 0 equals. Okay, and 20x squared minus 12x. That's all the zero function says. Now after that, we're just doing what we've been doing. So let's make sure one side 0 it is. So next step, take out factor using GCF. I can take out a factor of 4 and x, leaving me 5x minus 3. Our next step then says to solve what we got by pulling the pieces apart. 4x, 5x minus 3. Setting them to 0, just like we've been doing, and solving. So divide by 4, x equals 0. Here, add 3. 5x equals 3. Divide by 5. So x is 3/5. There it is. That's simple. The only difference between what we were doing before in zero function, replace f of x with 0. That's simple. Alright, so last one, and I'll work this one with you. This is our last problem. So here we go. Let's change this. Change f of x to 0. 20x squared plus 30. Oops, not 20, it's 24. Fix that, hold on. 24x squared minus 30x. Okay, now factor using GCF. 0 equals, now I'm going to take out a multiple of 6 and an x. So I'm left with 4x minus 5. So I'm dividing everything by 6x. Now from here, let's pull the pieces apart. 6x, 4x minus 5. Set them to zeros. And solving. Divide by 6. X equals 0. And here, add 5's. So 4x equals 5. Divide by 4. So x is 5/4. And it's that simple. Alright, so that's the end of this lesson. So again, hopefully you learned something. So again, if you need to, watch the tutorial video again. And if not, well, get your homework done and I will see you in the next lesson.